Okay, good afternoon. My name is Roberto Raguseo. I'm working for Kriu Ltd. I imagine that here everybody could speak Italian, me too, of course, but I have to do this speech in English. So if you don't, during the speech you don't understand some words, sentences, please stop me and I'll try to repeat and try to explain better. So, first of all, I think you are, today you are brave, sorry, you are brave people. Do you know why? Don't imagine where we are here. Okay, I just realized this morning, and I felt a little bit anxious about this, because this is room 13, and today is April, it's Friday, April the 13th. So, I'm not superstitious, but I beg your pardon, and I want to touch this before starting. So, it's impressive, the coincidence today. So, let's start. Have you ever worked in a network operation center? Do you know what is a network operation center? No? You not have an idea? Okay, I just tell this brief story. Working in a network operation center was one of my first job in the career, more than 10 years ago. What is a network operation center? Imagine a room like this, without windows, with artificial lights, a place where is open 24 hours a day, all the week, and full of this kind of monitor, full of monitor. What is in this monitor? There is the ELF, all the information coming from the ICT infrastructure of a big, of course, of big enterprises. And you'll find in this kind of room many people like you looking at a monitor. Of course, this is my experience was kind of nightmare. I'm talking more about 15 years ago. So we had a data center to monitor with thousands of servers, applications, and we had a lot of monitor. Each monitor displaying alert, alert coming from the hardware, from the software. And it was a nightmare because we had to pay attention to this, alert, red, yellow, green. Many times we had a duplicate information coming from different monitoring tools. It was also very stressful work because as soon as we had a problem, we had our boss call us and says, why don't you tell me there is a problem with, I don't know, the email server? So we were a group of 10 persons, all stressed. And my desire at that time was, my God, I just wanted to have just one software that could aggregate, correlate, clean all these useful information and the duplicate information coming from the ICT infrastructure. And suddenly, that software came. And it was a family of software called ICT Event and Correlation Analysis Tool. Exactly what I'm going to present here. So, we'll start the presentation from ICT Event Management. which is the traditional matter that, because of the exponential explosion of data, is becoming big data management. You understand now what I'm talking. So this is the agenda. We'll start with ICT Event Management. I'll show you what was the problem until a few years ago. The architecture of Kriu, the solution that we built in our software laboratory in Dublin. And then I show you how is this area and this tool is evolving toward what is called AIOps, which is a combination of big data and artificial intelligence, machine learning algorithms. So that was my job in that room, in the network operations center. We have to avoid look at these first sentences. We have to avoid incident. That an incident is an unplanned interruption for IT services or a reduction in quality. You know that interrupting an IT services or reducing the quality means that means that the core business of an enterprise, which is basically based on IT infrastructure, will decrease performance. And of course, the company will lose money. So my job, and this job is very, very, very important and useful for the core business of an enterprise. Every type of an enterprise, from gaming, banking, luxury, and so on. So, what are the benefits of this kind of tool? This is a tool that is able to detect events that are coming from all different monitoring sources. You know that today there are a lot of monitoring tools, open source, a lot of open source tools too that are very used, like Nagios. Do you know Nagios? I think you know. But there are also monitoring tools for network, for example, like SolarWinds, is very spread, and for tools specialized for application, end-to-end, for monitoring the end-to-end transaction, and so on. So we have a lot of this information that comes into our IT event correlation Kriu, and it can deduplicate, filters, and correlate all this information, trying to reduce what is called noise, because you know that if you have a lot of data, of course, it's the same having no data at all, because you need to filter and correlate. But what else does basically the tools? Not only aggregate, correlate, but also enrich the information. Because as soon as your hardware, your application have a problem, it's very important in order to be proactive or reactive before in solving the incident, before your customer tell you, I have a problem, is the ability to add useful information to data and event coming from monitoring source. For example, suppose you have a server that is down. Of course, okay, you know that the server is down from Nagios, for example, no? But you also, you as a NOC employee, you need to contact suddenly the person who is the owner of the hardware. And of course, if you do that manually, like I used to do in the past 15 years ago, it's a nightmare. because maybe you have you have the information in your notebook, or you're forced to ask your colleague, and it gives you maybe the wrong information. So it's very important to have a tool that automates this kind of notification. And that's exactly what Kriu does. It enriches the event with and automates the reaction with information that point exactly to the person and to the steps, to the process to follow in order to remediate the problem. So these are the basically feature of Kriu. It's okay? Okay. So that was the traditional playground. That was what I found when I started working 20 years ago. This was the typical ecosystem you find in a data center. I'm talking in the era before virtualization, where all the enterprise has their own data center with physical servers and application organized in silos. So you had the user that with a start transaction that cross the firewall first, then the web server, the application server, the back end of the application with the DB server, and back to the user. This was the typical environment we found. Things are changing, have completely changed. How many of you work, I think that, how many of you here works in the IT operation? No? Okay. And okay, this is the actual scenario that you find in your company, if you work in the IT department, basically. You don't have, maybe nobody has of the amount of physical server you have is very, very, very reduced. Because you have now cloud provider that can provide you with infrastructure as a service, or can provide you platform as a service, or software as a service. There are a lot of acronyms about as a service, but basically these are the three as a service things. You have mobile. You have your employee using their own devices for accessing the infrastructure, and you have to control their devices. You have microservices provider. You have a different kind of database. 10 years ago, I just know one type of database, the SQL-based database. Today, you have a lot of databases, NoSQL database, and so on. So the amount of data that is produced by all these complex infrastructure has exponentially grown. And that is leading to another problem. We have to manage big data. We have a big volume. We could have a big volume of data, much more bigger than in the past, than 10 years ago. You have not only structured data, you have also unstructured data. So you have a variety of data coming from a web, from a lot of sources. In the past, you just have one type of protocol, the so-called SMP protocol, and also the SMTP. So basically, events coming from the source use only these two protocols. So you have to interpret and monitor this one. Today, you have a lot of protocols. And so the problem is changing. It's becoming, so as I said before, a big data problem. And you need to develop also your skill, and thinks in terms of big data management. This is a slide that I downloaded, and this is different colors are in yellow, data created inside the enterprise. In the past, you just only have data created inside the enterprise. Today, with hybrid infrastructure, you have also data coming from outside. So the total amount, I don't know if you, here, there are some dates. This is 2009. This is the total data that our product, this kind of product has to manage. This is 210. This is 250, and that's the prediction to 2020. We're talking about zettabyte. So our data are literally exploding. Okay, so let's talk about what we are doing as a Kriu. So we're starting for a traditional, we started our journey as a company approaching the traditional problem. So this is the architecture, the high level, it's not an architecture, it's the high level environment where our Kriu generally works. So you can find here different sources, the one that I talked before. You have traditional SNMP, you have traditional email server sending event to Kriu. You have a command line that Kriu provide that allows you to send the event manually, or you can embed it, for example, in your code. For example, for who knows SAP, we can monitor jobs, SAP job, embedding our probe, our command line, inside the ABAP script. So in this way, we are able to track and monitor what code, SAP code is doing in the production. And of course, we can also get data from external database as input. So at the moment, we just cover these sources. That is, there are the traditional sources. This was until a few years ago, 2-3 years ago, it was okay having just this. Today, no more. So this is the flow. Data comes in. As I told you before, one of the most important feature of this tool is enriching, adding useful information to this alert, to this event, coming from external database. This is, for example, what we do is enriching with information coming from the asset database. Because in an enterprise, each asset, a server, a router, network devices, and so on, as an owner, has ownership information attached to it. So what we do is we automatically query that kind of database. Could be also a database on the web. We use web services for querying it. And we join this information with the one coming from the monitoring. And what we do? Here's where it comes the intelligence of the tool. This is a programmable tool. So, having data, you can decide what to do with the data. We embed, for example, a JavaScript engine and a Lua engine that allows you to manipulate this data according to your business rules. Of course, we have some rules that are also predefined. For example, what is called the deduplication. I know the software is able to recognize event coming from different data sources that has the same informational context. So you want the knock operator, the famous knock operator, we won't see different events and different information on the console that has the same information. But they just see one record with that information. And a counter that say, hey, we're collecting many events that has the same information. So, thanks to this programmable logic, you can automate the reaction. Typically, in the IT operation environment, a reaction could be, okay, not simple reaction. I sent an SMS, I sent automatically an email to the owner, to the manager responsible of the IT services that is affected in that moment. This is the most basic feature that Kriu does. Other action, for example, you can open a ticket, for example. Open a ticket and fill, for who knows a typical trouble ticketing tool or service desk tool, you can open a ticket with information like, for example, the priority. You can have information like the service affected, the asset, the place of the asset. You can geolocate. We do also that because we have an integration also with maps of the data center. You can also locate where the problem is, where your asset is, the location of the asset affected. And for example, so you can open automatically an instance and a ticket full of information. And what does it mean, having a ticket full of information? Of course, this means be much more reactive and shrink the time, of course, the mean time between for repairing, for example. And that means, of course, working in an efficient way. Another thing that we do that is very useful when we have a critical situation. Imagine a company that is selling online. Imagine something happens that broke the service, closed the service. So this is a very critical situation for the company. What we do, and we automatically start a chat room between, of course it is an internal chat room, of a company chat room, that automatically put together all the people that are able to work on that fault. And this, of course, decrease the time, the reaction time. And all of this we can do automatically, based on your business rules. It's okay? Am I clear? Okay. So, this is the high-level architecture of our solution. So we have a receiver, a component receiver. This is written in C++. Actually, we support Linux, CentOS, and Red Hat. Why C++? Because, as you can imagine, the most important feature of this component, the receiver, are performance. It has to process very quickly all the events coming from the external sources. We have the receiver, and attached to the receiver, we have a first level of processing. You have Lua engine, but I missed also the JavaScript engine. And as soon as you receive the event, you can just starting filter there and write your logic. This is what we are doing here in the lab. So I think as soon as we finish, maybe you are in time. If you want to experiment this, you can follow the lab. I think you're still on time. Then the correlated and the cleaned information is passed to the database. Actually, we have a MySQL database, but we are planning to also to migrate to NoSQL database, of course, because we need to manage big data. Then we have a server. A server is a second level of processing. It offers you a high-level processing. So you have already cleaned your raw data coming from the environment, and you want to maybe program a high-level logic. You want to refine more. So you have the possibility here in the server, in that component, to apply other logic. Then you have the scheduler. The scheduler is a component that schedules, of course, but the important things, and you can attach to the scheduler other programming logic, which whatever, of course, is something that is external. So you can have C logic, Java logic, R logic if you want to implement some statistics. Python, you can have PHP. You can attach to the scheduler whatever you want. And this is the third level of processing. Of course, this is a level that usually integrates the third-party application. Because in the scheduler, for example, you can implement a logic for automatically open a ticket, for having a statistical process over your data. For example, if you want to implement a linear regression on your, I don't know, maybe the CPU usage of your server, of network bandwidth, and so on. And, of course, we have then a web front end. I show you, which is basically composed of two parts. We have a web administrator console and a user console. The one that I told you at the beginning, the one that is in charge of NOC operator. Then I'll show you. So, this is the administrator web console. You have a menu on the left that enable you to set all the scheduler policies, the take action and notification policies, and all the settings for the user console. You have here an overview of, in the middle, this is an overview of the internal database performance, and a summary of the user you created, the script you created, the logic, the action you created, and notification. And this is the console, the event console. As you can see, we have different colors that match different priority, urgency. Black means your infrastructure is having very heavy problems. Green means that it's a kind of information, and so you don't have any problems. The technology we have used for this. These are all the programming language that we have used. We used C and C++ for the backend. Remember the receiver, the main component, the receiver, the scheduler, the server. We have JavaScript and Lua for first and second level filtering and correlation, event correlation. We have the PHP, which is basically the script that we use to attach to the scheduler. And they are able, for example, to enrich the event querying external database or interfacing with the third-party software. And these are basically technology that we use for the front end: Bootstrap, jQuery, Dojo, and Twitter Bootstrap. Of course, we have Apache Web Server and MySQL database. So, now I want to show you how we usually work. You're on time to go to the lab and try exactly this. So, for example, if you want to integrate our Kriu with Nagios, you follow typically these 3 steps. Send event, so with our command line embedded in Nagios, you can send Nagios alert to the Kriu console. Then, as soon as we have raw data reception, we use the JavaScript logic to understand where the data is coming from, and then apply the proper logic. Then, third step, the color is event processing and displaying. So, as soon as you have cleaned, you have aggregate and correlate your event, at this point, this event and enriched is put into the database and ready for being displayed in the user console. So typically, this is what we do. This is the Nagios administrative console. So we embed into Nagios the command line, our command line, and the parameters that we have to pass to the command line. Then we write here the logic for the JavaScript processing logic. We have basically two files, the standard JS. Think about standard JS, the logic, the first logic that is run by Kriu. Basically what it does, it recognizes the sources. We have mapped a lot of sources out of the box. Of course, you can map into that file with very simple JavaScript. You can map your own source. So the ability of this product is you add your monitoring source, not only the out-of-the-box that are provided with the product. Standard JS so recognize the source and say, oh, okay, this is a Nagios event. Okay, so I call automatically the logic, the processing logic that has been built for Nagios. And what happens there? Basically, this is the logic where is able to translate the Nagios language to our Kriu language, to a standard, because the further processing are based on a common standard, the Kriu standard. Third, as soon as the event has been processed, is ready for being displayed in the user console. So, very simple. Of course, I simplified this flow. This is typically the flow that is followed from the monitoring source to the user console for the knock operator. Another example is this. Is automatically creating an incident, as I told you before. So, first things that happens, the event is enriched. so information from third-party database is added to the original event. Think Nagios. We use basically out-of-the-box PHP logic. And of course, we need also to create a web services for communicate to OTRS. We have a best practice with a lot of service desk from, for example, Jira. We have ServiceNow, OTRS, which is an open source service desk that we have used in the past. But basically it's the same. The process is the same for every service desk. And then third, we add the logic for opening the incident. And we put this logic into the scheduler. Remember, the scheduler is a component of Kriu. So this is the logic for, these are code snippets, of course. We create a table before where to store events. We enrich the events querying the external database, the CMDB database. We then implement the logic for opening the incident and create the REST API for interfacing to OTRS. And then we added this logic to the scheduler. Okay, so I told you that things are completely changed. Game is becoming much more difficult because we have to cope with big data. And the traditional solution is becoming obsolete. So that's why last year, Gartner started a new discipline, the evolution of IT event management discipline, called IOPS. IOPS introduced two new terms that you, of course, you know very well: big data and machine learning. And that's the typical architecture, how it's becoming. So you have an event management core that is enhanced by machine learning algorithm and big data management capacity. Around you find, of course, the monitoring sources. You find the automation rules and the service desk integration. This is how the discipline is becoming. And of course, we as Kriu are also updating, upgrading our software. But, of course, this is, I'm talking about the future, because at the moment, the situation is this. I think, you know the hype cycle of Gartner. What does it mean, that curve? All discipline and products that are on this slope are discipline and products that are in the early phase. What does it mean? Many of these experiment prototypes will fail, maybe 90%. And only best practice will survive. Of course, at the moment, we don't know that. It's a kind of natural selection. And we are in that phase. So at the moment, only 10% of companies are adopting AOPS. That's why this is in our roadmap, but at the moment we still don't have a solution, an IOPS solution, because we are small. We have, of course, we don't have, we are not IBM or these the tech giants. We want to see what our competitors are doing, because we don't want to make their mistakes. So now we are observing and prototyping. Simply to prototype is this kind of solution. This is a typical big data platform based on Hadoop framework, for example. So you have the data, you have the ingestion of the area, you have then the processing, and then the insight on your data. What we are going to do with our product is integrating with this. We'd like to integrate with this environment and let this environment easier to use. So we are developing an Hadoop adapter for ICT, of course, for IT operation, of course. We're developing an Hadoop processing adapter too, and we're going to develop also a database that is able to provide all the insight and the report, dynamic report, that comes, of course, from the processing. So our idea is integrating with the Hadoop ecosystem. And that's all.